Okay. So Muckeye Technologies, we help clients to digitize their ore. I'm not sprinkling AI on anything though. The ore in underground mining projects that arrives at the draw point isn't always what was planned. So despite logging and exploration and planning, what actually arrives at the draw point is sometimes the fragmentation patterns is different, the flow state is different, it's wetter, the grade's not there. So we're helping clients to map that better using a multi-sensor hardware platform that we can deploy in the mine, taken right to the draw point. So typically what's done now is the engineers go around daily, weekly, monthly, and they take visual observations, they do periodic manual sampling. It's the best available information. The engineers do a great job. They're out there in the gumboots daily getting the best information they can, but this is an intermittent process. It's subjective and it's slow. This can lead to everything from unexpected feed in the mill and at worst safety incidents. And in the case of mud rush, catastrophic safety instances that can close a mine. By no means do we believe that our technology can prevent a mud rush, but we hope to be able to make them more observable and to be able to give operators more information about these processes that are happening and how the conditions are changing. So what we're doing, that's me there with one of our prototype handheld units. So what we're doing is we develop these multimodal sensors, so camera systems with depth imaging and spectrometry, and we're building a digital model of each draw point. And the eventual objective is to have a full network of these sensors deployed throughout the mine to gather continuous real-time data about the actual ore in the mine, because that's the first time that they actually lay their eyes on it. And then by the time it gets to the mill, they've already have quite a bit of a heads up. And so that can feed into existing digital twin models of mines and mills that are there. So our system is more the hardware front-end sensor that's measuring the actual material properties. So one of our flagship applications then is the mud rush risk assessment and detection. Moisture content and particle size, fragmentation patterns. Seems mundane, but we get a lot of interest from clients, especially with the heightened interest around mud rush incidents in the last years and months. Just a quick thank you to CEMI and to be involved in this fourth round of proposals now. And so with their support, what we're doing is we're overhauling a key part of our data architecture. So again, this is something we've worked on over the past couple of years. Unfortunately, it's not an easy solution that we can just let cloud take over on, because we have a data architecture where we're fusing multiple sensors, and it's quite a significant undertaking, as well as developing new models to really assess gradients and textures in the ore, which is not something you can throw a pre-existing model to detect cats and scooters with. You need to develop models that actually work and detect the features of interest in the mine that miners actually care about. Oh, hey, that drop point's hung, right? For example. So we have the second phase of a trial coming up later this year or early next year. Hoping to get the equipment installed on a mobile autonomous vehicle. And we also have active discussions with other operators, quite advanced, to get into their mines to show them what our technology can do for them.